All right, Trinity Classical Academy, this is your bonus video. It's like, so back in my day, we used to have these things called compact discs that had, songs on them instead of just downloading them instantly off of the newfangled internet. We had these CDs, we called them, that at the end of the last song, oftentimes there would be just a long pause, like a minute or so of quiet space on the disc, and then another bonus song would come up. This is the bonus song. It's you're welcome. A lot of people have asked about the candle holder problem, problem number 26 on the Heinous final examination, and I did not have enough time to give it full justice during the Zoom meeting. And some people were still asking about it, so I'm like, you know what, okay, let's do it. So here it is right now. At the time of this recording, y'all are doing your namesake presentations, and I wanted to see if I could crash that party, and I was not able to. I have people coming over, moving furniture. I have just a lot of stuff happening right now. So unfortunately, I'm sad that I could not see your final presentations, but here we go. So number 26A. It asks for the surface area of this entire candle holder thingy. The first step that we want to do is we want to break down into parts what are the surface areas that we're going to need to find. I'm just going to use these top three colors here. So the first one I'm going to highlight in yellow. We have this part right here. It is the, I'm going to call that the bowl. And my computer is being really weird. It's not recognizing my finger lately. The bowl, that's not even how you spell bowl. Come on, computer. Come on, come on. I hope the recording comes out without being too choppy. So the bowl is half of a sphere, right? The bowl portion is a hemisphere. So we're going to I'm gonna come back to that later. First, we're gonna identify our parts. Then I'm gonna call this the top. This is the top. All right, we have the top. I want to point out that the top is a circle. You might say, hang on, Mr. Bourgeois, what about this bit of circle here in the middle that's removed? Well, it's not completely gone, it's just down here, right? So that bit of circle, if we calculate the area of this entire circle, it would just be just fine to just do that, the straight up area of a circle. We don't need to try and subtract this little area of the circle and then add back this little area of the circle, because this little area of the circle is the same as this little area of the circle. So let's not make it really hard on ourselves and calculate the area of 3 circles when really we can just get by with calculating this big circle and we're done. Because this little circle right here is what would be subtracted up here and then later added back. So we're just going to calculate this whole big circle. We're going to call that the top. Last, we have one more piece. It is I'm going to call it the tube. It's this little rounded area on the hollowed out inside part, which is going to be, we're going to use well, I'm not going to spoil it. We'll get to that later. I feel like my processor has just been running kind of slow lately, and I just restarted my computer before I started this video. So, okay. So the bowl. How do we find these? How do we find these surface areas? Well, let's get our formulas down. So the bowl is like a sphere, right? If we imagine a perfect sphere and then we cut it in half, a surface area of a sphere is, let's do this, 4 times pi r squared. 4 pi r squared, but we don't have the whole sphere. We're only looking at, in this bowl thing, we're only looking at half of the sphere. So we're going to do that times a half, or divided by 2 if you prefer. But just kind of quickly looking at this, we can see that 1/2 of 4 pi r squared is really just the same as 2 times pi r squared. So I'm just going to say 2 pi r squared and simplify things. So 2 pi r squared will get us the surface area of the bowl portion. So that's going to be the one of the biggest chunks that we got. Next, the top. So this is just a circle. It's just a circle, and I already explained that we don't need to worry about this little piece because it's as if that piece just slid down a bit, but it's still part of this whole circle. So we're just going to call that pi r squared. Pi r squared. Next, the tube. If you remember, the cylinder has three parts to it. It's got circle, circle, and then they call it the curved portion, or the sides of a can of soup. You have the top and the bottom of the can of soup, and then you have the sides of the side of the can of soup, the rounded side. I don't know if you call it one side or two. It's curved. I'm going to call it the tube because I think that's the most descriptive and clearest way to describe it. So the tube, part of a cylinder, that formula is 2 times pi times radius times height. Now then, we are looking at different radiuses. So if we add all three of these pieces together, that would give us the entire surface area of the candle holder. So if we were going to like paint it and cover all of the nooks and crannies too, these three pieces would give us the entire nooks and crannies. So we take all three of these pieces, we add them together, and we will get our surface area. So we plug the values in. So the bowl, so looking at the thing, the bowl has this hole right here is 2-inch radius, and then this is a 5-inch radius. I did not draw it to, so from this edge of this inner circle to the edge of the outer edge of the top, or sorry, yeah, outer edge of the top gives us a radius of 7. So it'll be 2 times, let's see, yeah, so pen, so 2 times 7 squared times pi, which would be 49 times 2, which would be 98 pi. And they say to use 3.14 to approximate, so it's going to be 307.72. And 307.72. Next, for the top circle, again, the radius is the same as for the sphere calculation. So it's just going to be, instead of 2 pi r squared, it's going to be 1 pi r squared. So total, we have 3 pi r squared between the top hole and the top. But let's just keep it simple. Equals. So we have pi times 7 squared, which equals 49 times pi, which is 153.86. And then the tube. This tube has a smaller radius. This radius is 2 inches, or 2 centimeters, excuse me, 2 centimeters. I think I used the wrong units before. And then the height was 2.5 centimeters. So the height of the tube is 2.5 centimeters. So we're just going to plug these values in. 2 times pi times 2 times the height, which is 2.5. So 2 times 2 times 2.5 times pi gives us, when we calculate it, 31.4. We just go ahead and sum all three of these numbers. Zip, zip, zip. We're going to get 492.98 square centimeters. So that solves us A. Pause this, take a screenshot if you want to. But that's how we do it. So I labeled all my parts that we have to calculate. The bowl, or this entire, and it's not just, I know it's kind of confusing when we're dealing with three-dimensional figures on a two-dimensional screen, but this bowl is going to be all the way around. It's the entire dome shape right here. And then the circle, coincidentally, is 1/2 of the surface area of that. So coincidentally, it works out to 2 pi r squared and then pi r squared, and since the r is the same, it's like basically 3 pi r squared. We could have just done that in one step, but I didn't want to confuse you guys. So bowl, plus we have this circle up at the top, which we don't need to separate out the little circles because they add up together. And then we have this tube. So as you stick your hand down the sides, or I guess since it's only 4 centimeter diameter, you'd stick your finger down in there and realize, aha, there's still surface area down in this tube as I go down towards the center of the hemisphere. And that equation is 2 times pi times r times height. And that r is different, it's 2. So maybe I over-explained it. But look at B. So we want to know the volume of the whole thing. So let's say you're working for a manufacturer or something, and they say, hey, how much material do we need to make this shape? We have a mold. We're going to fill it up with molten glass or some such material, and we need to know how much glass we need to make one of them with. We need to know the volume of this entire thingamajobber. Man, my computer's being choppy and slow. I don't like it. Okay. Oh, you know, I missed an opportunity to go smibbity bibbity 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 bibbity. The volume, so we have the volume of a hemisphere, which is just going to be a sphere and then half of that. So we have hemisphere. I wonder if I put my computer in airplane mode if it would work better. I don't know why it's being so slow. So we have the hemisphere, which is half of a sphere. So let's write the volume of the sphere. 4/3 pi r cubed. Come on, little finger that could. Pi r cubed. There's an r there. And it's half of that. So because it's half of that, we can simply just straight up distribute this 1/2 into this term. This is only one term, guys, because everything's multiplied across. So it's all considered one term. We don't try and distribute it to each little letter in the term. So 4/3 of pi r cubed is, or time divided by 2 is the same as let's just divide this by 2. So instead of 4, it'll be a 2. So 2/3 pi r cubed is the volume of a hemisphere. But we need to subtract this piece that's missing right here, the tube, the cylinder. So to subtract, there's like a void of cylinder space in there. The cylinder void. And the volume of a cylinder is pi. It's the same as a circle. So we look at the circle on the bottom, pi r squared, and we multiply it by how deep that cylinder goes. Pi r squared times height. So now, let us plug this in. I'm just going to zoom out because easiness. So we plug those values in, right? So 2/3 times pi r cubed. This r, the r of the whole hemisphere is 7. So it's 7 cubed times pi times 2/3. I know I just wrote them in different order. It doesn't matter, because we're just multiplying all of them together. You multiply those all together and you'll get 718.01, which I think they just drop it because the cylinder that we calculate is going to be pi times the radius. Boy, what is up with this? It's being weird. Pi, and then the radius is 4. I suppose this is the perfect time for my computer to start acting weird since school is just about over anyway. Times the radius squared, so the radius is 2, and I just squared it for you. Let me write that out. 2 squared times the height, which is 2.5 centimeters. So we multiply this across. They say to use 3.14 to approximate, and we get 31.4. But because the cylinder is not positive, it's a void, we have to subtract it. We're going to subtract this minus this. And when you subtract that out, you should end up with 686.6 centimeters cubed should be your units. Cool? I thought so too. Smibbity bibbity 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 bibbity. Come on now, bibbities. Ooh, come on, you can do it. I restarted my computer, I closed all apps. I don't know why it's being slow. Maybe my computer has some kind of a virus. Not the coronavirus or the murder hornets. All right, let's zoom it back in again since I feel like my candle holder got far away. Now the question is asking us, suppose we stick a candle in there. Suppose we snug a candle on in there. and it sticks out a bit. So the candle, it has a height of 8, so it's 8 centimeters high, and it says it has a diameter of 4 centimeters, which means its radius is 2 centimeters. So it fits snugly into this hole, which is the idea of the candle holder, is that it's supposed to hold a candle. And so the radius of the candle is 2, and its height is 8. However, it asks us what's the surface area of the amount of the candle that sticks out. Let's go ahead and draw that candle, why not? So the candle is going to be like this. So there's our candle. And it's going to have a radius of 2 centimeters. And its height, since we're calculating the surface area that is sticking out, we're going to ignore everything that's underwater, inside the glass. We're just going to look at how much is sticking out. So we take 8 and we subtract this height. This height is 2.5 centimeters. 2.5 centimeters. So what's left, 8 minus 2.5 is 5.5. So 5.5 is our height. So now we're going to calculate the surface area of the tubular part. So surface area of the tubular part, so we have, once again, we have pieces we need to calculate separately. We have tube, and then we have the top, this top right here. We only have one top. We're not going to calculate the bottom because, like they said, only the part that's sticking out. So we don't count the bottom. We only count the tube and the top. So the top is going to be pi r squared. It's a circle. And the tube is going to be 2 times pi times r times h. Plug those in, guys. So moving over. So 2 times pi times the radius, which is 2. This computer's frustrating me. Times the height, which is 2.5. Multiply that across. You're going to get an answer. It's going to look something like 69.08. 69 and 800ths. And then the top is pi r squared. So the r is 2, and then we square the 2. So 4 times pi is 12.56. I think I might have mixed my numbers up because I did this out on paper first, and I'm just copying off of my paper. So then what do we do, guys? We add these two numbers. We additionize them together. And that's going to equal 81 and 64 hundredths centimeters squared. Groovy, you guys. So that is that. I'm going to save this, book it, mark it. It'll be good. I miss you guys. I'll see you next week, and then sometime ever after. Maybe I'll sing that sad song by Green Day about something unpredictable, and in the end is right. I hope you had the time of your lives. Okay, that's it. Goodbye.